Good afternoon, students. Today we will be studying about few numericals on channels, few numerical on information theory about channels. So in our last sessions we have seen that there are four types of channels that are being used in information theory. They were lossless channels. I will give you a back again. They were BSC channel, which we have seen yesterday. The first one was BSC channels. BSC were having two inputs and two outputs. So this was the BSC channel. You can have a look about it in my last lecture as well. After BSC, we were having lossless channels. So this kind of channels are called as lossless channels. Okay. In this, you are able to see one column will have only one element active. These are called as noiseless channels. Similarly, there are lossless channels. You can see about all types of channel in my previous lectures. So you are able to see here is lossless channel. This is a lossless channel. So in this case, you are able to see that there is only one element active in one column. And the last one is deterministic channel. The fourth type of channel is deterministic channel. So this is basically a deterministic channel. It looks like this. There will be one element active in one row. That means the number of inputs will be more, whereas the number of outputs will be less. So we have seen till now that there are four types of channels that are being used in the field of information theory. So from today, first of all, we will start with a small numerical on channels. Then we will come to know how to calculate the channel capacity. So before moving further, first of all, let us understand channels from numericals point of view. So we will take a numerical today. There is a question, there is a numerical, find the probability of getting y1 and y2 at output of BSC, that is binary symmetry channel. What is the probability of getting y1 and y2 at the output of BSC if the probability of input x1 is equal to x2 is equal to 0.5 and the channel matrix, that is py/x for a BSC, is given like this, that is 0.9, 0.1, 0.2, 0.8. So this is basically the channel matrix, and this is given to us in the question that this is the channel matrix for a BSC, and the probability of getting inputs x1 is equal to x2 is equal to 0.5. So we need to calculate the probability of output. So now, how we are going to find the probability of output? That is using the relation py is equal to pxi into py/x. So this is the basic formula that we will be using today to calculate the value of output. After calculating the probability of output, we will find few more things like joint probability and other things as well. So first of all, let us start with this thing, that what is the output probability for this kind of BSC channel. So the input is 0.5, input probability is 0.5 and 0.5. So input probability matrix is this, and channel matrix is 0.9, 0.1, 0.2, 0.8. So this is the main formula that we have to remember, that the probability of getting output is equal to pxi into pyj upon xi. You can write it like this also, yj upon xi. So now we will find the we will do this matrix multiplication. So 0.5 into 0.9 is 0.45 plus 0.5 into 0.2, that is 0.10. Okay, so after this 0.5 into 0.1, that is 0.05, 0.5 into 0.8, that is 0.40. So we are left with 0.55 and 0.45. So this is probability of y, getting y at the output. So probability of getting y1 at output is 0.55 for this channel, and probability of getting y2 is equal to 0.45. So this is how we can calculate the output probability of from any channel, the output probability using input probability and channel matrix. Now we will move on to the second part of the numerical, that is find out joint probability. For the same numerical, we will do one thing more. We will find joint probability for P x1 comma y2 and P x2 comma y1. So we are going to find joint probability as well for the same numerical. So how we find joint probability, that is P x comma y. So this is called as joint probability. We already know P y slash x is called as channel matrix, or this is also called as, this also means probability of receiving y at the output when x has already been transmitted. We have already transmitted x, so what is the probability of receiving y at the output? This is called as channel matrix. So now the formula for joint probability is Px, that is input probability, input signal probability in diagonal form multiplied by Py slash x matrix. So this is the formula for joint probability. So here now we will put the values of input probability in diagonal wise. So 0.50, 0, 0.5. This is input probability of x1, probability of x2. This is to be written in diagonal form. And then we are going to multiply this with the channel matrix, that is 0.9, 0.1, 0.2, 0.8. So now let's do this multiplication here only. 0.5 into 0.9, that will give 0.45. 0.5 into 0.9 has given 0.45 plus 0 into 0.2, this will give 0. 0 multiplied by anything will give 0. So we have done this thing. Now we will do 0.5 into 0.1, that is 0.05 into 0 into 0.8. 0 multiplied by 0.8 will give 0 itself. Now for the second row, 0 into 0.9, that is 0 plus 0.5 into 0.2, that will give 0.1. Similarly, 0 into 0.1 will give 0 plus 0.5 into 0.8, this will give 0.40. So we have received the joint probability matrix. We have been able to see the joint probability matrix. It is 0.45, 0.05, 0.1 and 0.4. So this is the joint probability matrix. So now we will write it first of all. So I will write down again the values that we have received from the joint probability. So joint probability is given by P x comma y. So here this was a BSC, that means both the inputs were 2 and there were two outputs. So the joint probability is written like this: P x1 comma y1, P x1 comma y2, P x2 comma y1, P y2 comma P x2 comma y2. So this is the matrix for joint probability in this case, in this scenario. And we have been able to find out its value after doing the matrix multiplication in the last step. So this was the matrix multiplication that we have done in the last step. So it shows 0.45, 0.05, 0.1 and 0.4. So it shows 0.45, 0.05, 0.1 and 0.4. So this was the values that we have calculated for joint probability in the last step. So from here we need to find two values of joint probability, that was P x2 comma y1 and P x1 comma y2. These were the two in the numerical.